Welcome to Math Tutorials. In this video, we are solving the miscellaneous exercise of Chapter 1, Relations and Functions, from the NCERT Mathematics textbook for Class 12, Part 1. The miscellaneous exercise has 7 questions that mix everything this chapter taught: injectivity and surjectivity proofs, relations on power sets, counting onto functions, equal functions, and 2 counting problems about relations. Here they are. Let's start with question 1. Question 1. This function squeezes the whole real line into the open interval from -1 to 1. The formula is x over 1 plus modulus of x, and we must show it is 1, 1, and onto. First, notice the sign of f of x matches the sign of x, since the denominator is always positive. 1, 1, case 1, both inputs non-negative. Cross-multiplying x over 1 plus x forces x1 equals x2. Case 2, both negative. The modulus flips the sign in the denominator, and the same cross-multiplication again gives x1 equals x2, so f is 1, 1. Onto for non-negative targets. Y between 0 and 1 is hit by x equal to y over 1 minus y. And for negative targets, x equal to y over 1 plus y works. Every y in the interval is attained, onto, so f is a bijection. Question 2, a quick one. The cube function on the reals. We must show it is injective. Suppose f of x1 equals f of x2, that is, x1 cubed equals x2 cubed. Cubing is strictly increasing. If x1 were less than x2, then x1 cubed would be strictly less than x2 cubed, contradicting equality. The same in reverse, so x1 must equal x2, f is injective. Question 3. P of x is the collection of all subsets of a non-empty set X. A relates to B when A is a subset of B. Is this an equivalence relation? Reflexive, every set is a subset of itself. But symmetric fails. The empty set is a subset of X, while X is not a subset of the empty set. Transitivity does hold, a subset of a subset is a subset, but one failed property is enough. Not an equivalence relation. Question 4. How many onto functions are there from the set 1 to n to itself? The key is that the set is finite, and the map goes to itself. The key fact from this chapter: on a finite set, a function from the set to itself is onto exactly when it is 1, 1. So onto functions here are precisely the bijections, the permutations of n objects. Counting permutations. The first element has n choices for its image, the next has n minus 1, and so on down to 1. That product is n factorial. Question 5. 2 very different-looking formulas, a quadratic and a modulus expression. On the 4-element domain, are f and g actually the same function? At -1, f gives 1 plus 1, which is 2. G gives 2 times modulus of -3 halves, -1, that is 3 minus 1, also 2. They agree. At 0, f gives 0. G gives 2 times 1 half minus 1, which is 0. Agree again. At 1, f gives 1 minus 1, 0. G gives 2 times 1 half minus 1, 0. And at 2, f gives 4 minus 2, which is 2. G gives 2 times 3 halves minus 1, which is 2. The 2 functions agree at every element of the domain, so despite the different formulas, f and g are the same function. Question 6. A counting puzzle on the set 1, 2, 3. How many relations contain the pairs 1, 2 and 1, 3, and are reflexive and symmetric, but not transitive? Reflexivity forces all 3 diagonal pairs, and symmetry forces the reverses of the given pairs. 8 pairs are locked in. The only freedom left is the pair 2, 3, and symmetry ties it to 3, 2. 2 candidates, with the pair or without. Without it, 2 relates to 1, 1 relates to 3, but 2 does not relate to 3. Not transitive, this one counts. With it, every pair is related, the universal relation, which is transitive, excluded. Exactly one relation survives. And the final question, again on the set 1, 2, 3. How many equivalence relations contain the pair 1, 2? Every equivalence relation corresponds to a way of splitting the set into groups. Containing the pair 1, 2 means 1 and 2 must sit in the same group. With 1 and 2 glued together, element 3 has only two choices: sit alone or join them. Those give the partitions 1, 2 with 3 apart and all 3 together. Two partitions, two equivalence relations. That completes the miscellaneous exercise and all of Chapter 1. That completes the miscellaneous exercise, and with it, all of Chapter 1. In the next video, we begin Chapter 2, Inverse Trigonometric Functions with Exercise 2.1. Thank you for watching. If you found this video helpful, do like it, subscribe to math tutorials, and share it with your friends.